Good morning, everyone.
Good morning.
Good morning. Welcome back. Yeah. Okay. Let's start. I think it's on time. Let me share my screen. Okay. So I think last lecture we're talking about a P2P application, right? Still remember we were talking about um, how B2B connection, right, or application such as BitTorrent can benefit the file transfer or downloading, right, the file. So the general idea is that if you have only a single server to serve at multiple or numerous of the clients, right, for file transfer or downloading, and it's not scale very well. So we want to have a more peers, right, like clients to join the network as a server function, right? So if more clients can provide the service to other people, then the network will be self-scalable, right? So more peers join and they can provide higher aggregated upload and download rate, right? So that's the general idea about the P2P application. Very classic or famous application is BitTorrent, right? So we talk about some scheme there. For example, every how many? I think it's 4 or 5 seconds, right? To check uh, the top 4 users that provide higher upload and download throughput to you, right? So you will reward them. So that's some scheme there. So that's the general idea for P2P model and some application. Okay, so I think at the end of the last lecture, we also talk about the video and the streaming um, some context, right? So we talk about most of the people or users nowadays using the internet are watching the video, right? Watching the streaming, um, game show, many stuff there, content there. And the challenge is that how to make this scalable, right? Because about, for example, 1 billion of the users are watching something together, right? Simultaneously online. So how can we make it scalable? Okay, and also a challenge is that there's some heterogeneity there. Different users have different capability, different bandwidth of network, wire versus wireless or mobile, right? So the conclusion, the solution is that we should have a distributed application level infrastructure, right? We will talk about that later. It's content delivery networks, okay? But before that, we need to first understand what has been delivered, right? Just as mentioned, so the video, right? The streaming video, the show, right? So how it will be delivered um, across the network, internet, okay? So I think I end up in the last lecture talking about how different coding techniques, right? To um, to be performed on the video or the maybe the frames, right, of the video. So I think the video is just as the animation of the digital images, right? So for image, it's an array of pixels, each pixel represented by bits. So for example, yesterday I asked one of my graduate students to help me understand or compress some images. So they need to load the image from the image file to array, right? That could be a 2D array, and that array should have I mean, depending on the different format, but generally speaking, should have the 3 channels, RGB, right? Red, green, blue, right? So have a different channels with the information, for example, integers there, right? So they use um, integer represent for different um, RGB numbers, right? And they will, the picture will finally visualize your based on that integer numbers. Okay, so this is only about images, and for videos, every second there would be, for example, 24 images. That's just a video, right? So as I mentioned last lecture, if we want to have a high throughput to deliver the video or image, sometimes we may need to encode the image and decode the image. What is encode is decode? It's just like if you learn the computer algorithm class, maybe you know the Huffman encoding or the Huffman tree, right? So we don't need to exactly save the number of the, I mean, exactly save the original data as a fixed number of bits, right? So we can reduce the number of bits to encode an image as mentioned here, right? So for some, as I mentioned in last lecture, so for some images or frames, there is some similarity there. You don't need to even to save both of them, right? You can save the difference between them. Maybe you only need to save a very small portion of the image. For example, if the frame I and I plus 1, right? The people are running, right? This person is running. So maybe you just save the person's, the pixel representing this person, right? You don't need to save the background. You don't need to save a lot of other thing is not changed, right? It's not changed. So if we just save the difference between the 2 frames, then that would help you to save a lot of information, right? You need to save. So that's something, in general speaking, that's something, some technique we consider in the image or video encoding and decoding. That would help you to save a lot of data storage, or maybe save the time to transfer this data. Okay, and the encoding technique could be across different frames or different images, but also can within one image. For example, as shown here, the special encoding example. So you can see here the different value in the background that could be the same, right? So all the first several rows of the pixels are the same, right? It's just a purple. It's just a represent for the same information. So you can just use one number to save that, right? You can encode the image like first 10 rows, they are in the same number or same pixel, right? Just use a one number and how many rows or how many pixels they are repeated to represent that. Okay, so I think this is some information theory content for the encoding and the decoding. We can talk about some complicated compression or encoding techniques later, but here is some basic idea, right? You don't need to save exactly the original information. You can use less information, or you can use less storage or less number of bits to represent the image, right? So this is the representation or encoding techniques we talk about. And for the, as I mentioned, for the different image of different videos, you can use a different number of the bits to represent, right? Or to encode. So for example, here we have the 2 different types of the encoding, not encoding, just a representation, right? But you can also say the encoding. So we have the fixed rate encoding or variable bit rate encoding, right? So fixed rate means that, for example, every pixel you just use maybe 24 bits or 32 bits, or how many bits you want, right? And for the variable bit rate, as I mentioned, so if you are using the Huffman encoding, you are using a lot of encoding techniques besides Huffman, right? We have a run length encoding, if you search data compression, there are a lot of different data compression algorithms here, right? So for the variable bit rate, that means for different pixel, you can use a different number of the bits to represent that, okay? So for example, the famous example is MPEG 1, 2, 3, 4, right? Different MPEG format for, I mean, when I was a child, I watched the video using the CD-ROM, right? That a big machine has a CD-ROM. You can put the CD there and play the video or audios for you, but that CD is just kind of too small, or I mean, if you're comparing with the disk today, right? It's just maybe 500 or 400 megabytes video there. It's just if you want to play a movie, maybe you need to have a two CDs, right? Or two, okay, so the two DVD CDs, right? So we need to distinguish them, because at the beginning, we only have the CD, maybe for audio, right? After that, we have something like a DVD, right? The DVD can just save one film for you, but it's still, not enough. So now we often use the MPEG-3 across the internet, right? So the bit rate could be varied from the 60K bits per second to 12 megabits per second, right? So it can, help you to deliver or distribute more video or audios here. Okay, so here's the idea about the constant bit rate and the variable bit rate. The general idea, I mean, here I want to emphasize is um, you, based on the different image or videos, you don't need to exactly use the same number of the bits to represent the information, right? You can use a different number of the bits to represent information, especially for audio video. It can be lost something, right? But still can give you some perception, right? Or idea what is placed. So, so here is the idea. And about the streaming stored video, the simple scenario is that the video, or the audio, the image are stored in the server side, right? If the client requests to play the video, that content need to be delivered through the network to clients. But the main challenge is that the server to client bandwidth will vary over time, which is a challenge, with a challenging network congestion level. So the idea is that when you request the video from the server side to your client side, the bandwidth could be changed over time. Sometimes, if only yourself is using the networks, the bandwidth could be very high. But right, so for example, if you are in a Starbucks before the COVID, right? So if you are in a Starbucks, you share the network with some other people. If a lot of people are in the Starbucks, then the network speed could be affected, right? And how to make sure that the video can be still played very well or delivered to you very well. You can still watch the streaming video, not very uh, um, um, influent, right? You just play the video, but you need to every several seconds to wait some frames to be delivered to you. That would be painful, right? If you are watching the video, definitely you don't want to have this experience, okay? And also there is some challenge about the packet loss and delay due to congestion will delay play out or result in poor video quality, right? Let me check the chat. Okay, so here's a good note. Yes, MPEG is not the same as MP4. MPEG-2 is a video encoder decoder. Yeah. Okay, so thanks. Good note. And let's continue about the challenges here. So how can we solve this challenge, right? Different people have maybe have a different varying or variable bandwidth network, right? How can we make sure the video to be delivered still in a good quality and you don't experience some bad experience? Okay, so here is an example that here a streaming a video has been stored in the server side. Every second there would be 30 frames in this video. Okay, and the video, if you request or play the video will be sent to you, right, through the internet, and the video is received by you, play out at a client, still 30 frames per second. But as you know, we have some delay before between the client and your between the server and the client, right? The frame is just image, right? So as you know, we have some delay, the queue delay, the propagation delay, a lot of delay here, right? So it's not possible that you are playing exactly the same um, time point with the server side, right? They should have some delay. I mean, this is a, you may have some experience, right? So if you play a video, uh, if you watch the video, for example, in your laptop, and you watch the video in the cable TV, you watch the video in your cell phone, sometimes they are not synchronized, right? Some device could be faster, someone could be not faster earlier, but later, right? So they are not in the exactly the same time point. So here, because of the network delay, right? This is a fixed in this example. Okay, so if we assume that the network is very stable, right? The bandwidth is very stable, nothing is varying, so the network delay would be a fixed number. But this is the ideal case, right? You cannot guarantee your network is not varying and the delay is a fix. So how should we do? That's our question, right? So here also, okay, so here another note, this time client play out earlier part of video while server still sending later part of the video, right? So you can experience that you play something at the beginning, but the video has been, sent to you for the later part, right? So this is ideal case, ideal scenario, but we can experience some worst case, right? So if you for example, as I mentioned, if bandwidth is varying, right? So you experience different times of delay. If you continuous play out constraint, once client play out begins, playback must match original timing. But the network delays are variable, right? Jitter, so we'll need client side buffer to match play out requirements. Um, this is something you definitely know that, because when you play a YouTube video or you play some video there, you can see a gray um, bar right there. So you can see how much content have been buffered, right? Sometimes it's buffered very fast, sometimes buffered very slow, right? You can experience, and then you know that if the video has been buffered already, you can play that at any time, right? You can just uh, drag the video right to any point you want to replay or want to watch in the YouTube video, right? So that's something your client and the server will have some agreement, right, to send you some video or some frames to buffer, and you can play anytime you want. So here is a figure, similar figure, but there is not a ideal case, right? So there is some variable network delay. Okay, you can see here the constant bitrate video transmission, right? In the server side, it has a very, just as this video, right? The original video you want to transfer. But because of the variable network delay bandwidth, the content to be sent from the server will not be consistent, right? Could be changed. Sometimes send the frames more, sometimes send the less frames, right? It could be not exactly the same as the original video. Okay, so how we can tolerate or maybe because it's sent to you sometimes fast, sometimes slow. How you deal with that? So the idea is that, I mean, it's just simple, right? So your client have a control, right? So in your web page, they have a control, right? Even if the gray bar is buffered too much, they will not just play very fast, right? They just play as it's scheduled. So in the client side, it has some schedule here. Okay, it's just a play out delay, and it buffers some video, and it's still a constant bitrate video play out at the client, right? So the client side buffering and play out delays can compensate for the network added delay jitter, right? So it's like no matter how network delays you just play as you scheduled, right? But if the network is too slow, right? Once you watch to the point that has not been buffered, then you definitely need to wait there, right? To wait another buffer. And sometimes you can see that it's interesting. There are YouTube sometimes will not buffer all the video for you at one time, right? It just buffer some portion of the video, right? And once you watch some frames close to that buffer point, it will buffer something again. Okay, because the idea is that some people just open the video and watch portion of the video, will not watch all the video. Why YouTube need to waste its resource to buffer all the video to you, right? Just buffer something. And then if you keep watching the video and the YouTube server realize that, okay, you want to watch the later part, they will buffer something to you again, right? So send something to you again. So there is some scheme there to avoid over buffering or over sending you something. Okay. So the streaming multimedia, there is some protocol scheme here called dynamic adaptive streaming over HTTP or Dash, right? The server on the server side, it divides the video files into multiple chunks, and each trunk is stored in code at different rates, okay? And the manifest file then provides the URL for different trunks, okay, on the server side. And on the client side, it just periodically measures the server to client bandwidth. Sometimes it's high, sometimes slow, right? It's not guaranteed to be stable. And its consulting manifest requests one trunk at a time, right? As I mentioned, so here is the trunk concept, right? So I just mentioned that maybe you see in the YouTube, it just send a portion of uh, the 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 video to you, right? That could be multiples of the trunks, right? And it will realize that you need to further get another trunks or multiple trunks. They will continue to send you the data, okay? And request a one trunk at a time. They choose maximum encoding rate suitable given current bandwidth. So here is a good point. You can see that if you have a poor network or internet, video may be, YouTube maybe reduce the video quality, right? So for example, the best quality could be 1080p, right? So that's a very high resolution video. But if your network is very poor, YouTube could reduce that to the 360p, right? Or even to 144p, right? So it depends on the net and I mean your bandwidth, right? But the client plays an important role here to measure the bandwidth between you and the server side and your client side, okay? And choose the maximum coding rate suitable for the bandwidth, and can choose the different coding rates at the different points in time, okay, as I mentioned.
Does the server decide to chunkify the video file before it's requested, just like a pre-cache?
I think the video has been already chunked, saved in the server, and no matter who requests the video, the different chunks will be scheduled to send to the user or to the client.
Okay.
Yes, and that's also the reason I just mentioned, right? So why you watch the video but buffer, right? Just a portion of it. This depends on the server. If they want to send all the chunks to you continuously, or just maybe stop some time there, or some portion or some chunks there, right? They don't want to. They are not willing to send all the chunks to you at one time, or right? So they just want to save some resources. Okay. So this is some intelligence at the client side. So the client determines when to request a trunk, right? And what encoding rates they need to request and where to request the trunk. Okay. And so when, what, where is just a basic question, right? So when is what the buffers starvation and overflow doesn't not occur, and the high quality is what encoding rate, higher quality or lower quality, and where is sometimes you just jump to another frame of the point of the video, right? So they just need to know which trunk they need to request from the URL of the server um, is provided, and also the from the URL server is close to the client. So that's something we will talk about later. Um, Even if you are watching the same video, but if you are in different geophysical locations, for example, if you are in Pullman, if you are in New York, if you are in Los Angeles, um, if you are watching the same video, right? But they can request the video from the different URL servers because they want to make a best service to you, but different physical distance would give you different delay, right? So that's something we will talk about later. It's about a content delivery network, right? We want to make sure every user, if you are the developer, right? If you are the server developer or maintainer, you want the user to have the same experience, right? Not depending on the different locations, right? And sometimes if the video is, cannot be played very smoothly, the user just do not watch the video, right? So users are always impatient, okay? So that's something we will talk about later. So the streaming video is encoding plus dash plus playout buffering, right? The encoding at different rates and decoding, encoding, and dash is some intelligent approach, right? To have a protocol between the server and the client, and the playout buffering just give you the same number of the frames per second, right? Okay, so here we have already seen something about the streaming video played between send and request between the server and the client. Then we raise a very important question: how to stream content selected from millions of the videos to hundreds of thousands of the simultaneous users. That's the question, right? You have millions, maybe billions of the videos, right? But you have hundreds of thousands of even more users simultaneously watching the video. How you can manage such scale, high scalability, right? So the option one is we have the single large mega server. That's just a single point of the server, right? So I think we have already discussed a lot of things like a single thing versus a multiple thing, right? So previously we talked about the P2P and server client model, right? That's also a one single point of server and multiple clients versus every client or peers could serve, right? And also previously we mentioned the ISP, right? If we have directly connect ISP versus we have some regional ISP something, right? So single versus multiple or distributed, that's a very important concept through the network course, right? Or other computer system class, okay? So this is a very basic idea you should remember. So for the single large mega server, as a point here, so there is only one single point of the server, right? If it's a fail, then everything fail, right? It's not very reasonable. And also, if there is any network congestion, then everyone will facing the problem, right? So, and also it's a long path to distant client, as I mentioned. If I set the server at Seattle, right? I hope Los Angeles, San Francisco, Dallas, New York City. So people across all the nation will have the same experience, right? I don't want to, because San Francisco is closer to Seattle, they will have better service or less delay, right? That's not reasonable, right? It's not fair for New York City people, and they may just do not use my service, right? So this is not good because of the long path of distance to clients, and also multiple copy of video sent over the ongoing link, right? That's another problem. So simple, quick answer is that this solution doesn't scale very well, right? As we discussed for the client server model, right? It doesn't scale very well. We want to have something very scalable, okay? So another option is that we can have something like content deliver network. So what is a content deliver network? So I will play a video for you, but the idea is that it's straightforward if you don't dive deep there. So it's a quick answer is that you store and serve multiple copies of video at the multiple geographically distributed sites, right? I set different servers, one server at Los Angeles, one server at San Francisco, one server at New York City, one server at Dallas, right? I set different servers with the same piece or multiple piece of the video there, right? They save same contents. So if you are from Los Angeles, I just use the Los Angeles server to serve you, right? So let me play a video. That video from content distribution network company, but they have a quick explanation of what is a CDN, okay? I'm trying to share the video and the sound as well. Okay. So I think this is a Cloudflare. So I think this is a CDN company. Okay, so can you see my screen? I think you can, right? So let me play the video first.
You run a successful website that serves customers across the globe. Even after spending your hard-earned money directing customers to your site, visitors drop off before they get the chance to complete a purchase. What's happening? Modern customers are impatient. Your website load time has a tremendous effect on how long visitors will wait for your site to load. Research shows a 2-second delay can lead to more than a 4% loss in satisfaction, and most importantly, a 4.3% loss in revenue per visitor. Unhappy, impatient visitors leave before purchasing your great products, impacting your bottom line. The farther a visitor is from where your site is hosted, the longer it takes for the data to reach them, hurting website performance. That's where Cloudflare's content distribution network saves the day. A CDN is a distributed network of servers designed to load your website as quickly as possible. By distributing parts of your website, such as images and JavaScript files, closer to your customers, your website can be loaded quickly, keeping your customers happy and your profits high. For more information about how a CDN works, explore the Cloudflare Learning Center.
Yeah, I think this video doesn't give much more information about how they organize the CDN. But I think the general idea is very clear, right? And the motivation, I think, is very important. I want to let you know. So the users are very impatient, right? So if they experience some delay more than 2 seconds or 3 seconds, they just close this purchase. So they close the video, they close a lot of things, right? So how you can guarantee that the delay for the different geographically distributed users, right? So how you can make sure they have the same experience is very important. So as mentioned in the video or in the slide, we can have more CDN server, right? So deeply into the many access network, right? As I mentioned, you can put the different server on different locations, right? It could closer to users. Okay, so here's the number. So the 240,000 of the servers deployed in more than 120 countries. So I use an example just within the states, within the nation, but sometimes you need to have some international customer, right? From Sydney, from London, from Paris. So they have a longer distance, then you need to have some international server distributed there, right? And that's the reason maybe you need to go to some CDN company, right? Like the video I just played from some Cloudflare, some company, right? So they just maintain the different CDN server across the nation, across the world, right? You can use their service, right? So you don't need to worry about your personal business. You just give I mean, you just ask the better service from them, right? You provide the website, but you put the website on their content deliver distribution network. Okay, and also it's another benefit is we'll put less and smaller number of the large cluster in the point of presence, right? Presence of the points, I think, yeah, POPS, right? So near, but not within access network. So that means you don't need to maintain, the idea is straightforward, right? You don't need to maintain a very large server there, okay? And it would help you to reduce the burden or lower the load on the POPs, right? And you can have a better security because you just deploy or put the more server on the different geophysical locations, right? And then for the main server side or the POPS side, then they will have a less security problem, right? Because you will have a less user to request to that server, right? So let me check. Live streaming 3. Okay. So is this a question? So you're talking about this may not be possible for the live streaming. Yes. So I will show example. Live streaming, I think, is also possible. It's not impossible. So for video saved there, it's possible, right? Definitely possible. But for streaming side, I think the CDN could be also working, right? So we will show you another video later. But the general idea is that for the streaming video, they can also they can be also sent from different server, right? So for example, if the CNN, right, streaming video, they want to stream some show to you or games to you, right? They can be sent from different servers, not only a one central server. That's some similar idea. So, but I will talk about it later. Okay, yeah, okay. So it's the live streaming. Yeah, it's not actually. Yeah, that's the point. Yes. So yes. So good note. Yeah. So the live video is just you record something and streaming that video to some server side and use that server to broadcast the information, right? But how to stream or how to buffer that video from, for example, um, we have the, for example, Staples Center in Los Angeles, right? You play an NBA game, right? So they just record that the game and the streaming that video to the different servers, right? If you only have a central server, for example, in Los Angeles, right? The different people across the country will have the different lags, right? But if, for example, if CNN establish the content distribution network and have different servers in New York, in Seattle, in Dallas, people can watch the streaming show with the kind of the same lags or delays, right? But as I mentioned, this is not real streaming, right? They always have some delay, okay? So I will show some slides later for the, especially for living or the streaming video idea, okay? So here is a CDN, store copies of the contents of the CDN node. For example, Netflix stores copy of the Mad Men film, right? So the idea is that if you want to access or play the video and you request, send a request from the CDN will direct to nearby copy, right? Retrieve the content, okay? So if you, right, so this is the animation, right? They will find the best location for you or path for you that is not very congested, right? To deliver the content to you. Okay, so here is something I want to talk about is the over the top. So over the top is more like some streaming show or TV show or something here. So first, what is over the top, OTT? Okay, so OTT is a medium service, is a streaming media service offered directly to viewers through the internet. The OTT bypasses cable, broadcast, and satellite television platforms, the companies that traditionally act as a controller or distributor of such content. It's like, the idea is that in OTT channels, the content is delivered through the internet connection rather than through the traditional cable provider. Okay, let me play a video, also another video, to give you a quick idea how CDN would be beneficial to the OTT. Okay, so simply speaking, that you watch the YouTube TV, right? That's the OTT. You don't need a cable. You just it's not like you don't need cable. The content is bypass the cable. Okay, so it directly send from YouTube CDN server to your site. It bypass the cable company, bypass the broadcast, bypass the satellite television. Okay, let me first play a video here. The video, I think this video is interesting. Give you some examples here. Okay, so this is the OTT. This is over-the-top television. It's specific for television, but OTT could be for other messaging or for voice, but this video is for the television. Okay, let's look at this video.
Over-the-top television, or OTT, refers to the delivery of TV and film content via a device that connects to both the internet and the television. The term over-the-top is in reference to the fact that OTT devices go over a cable box to give users access to TV content. According to eMarketer, in 2019, nearly 55% of the U.S. population uses OTT streaming services. OTT can be accessed primarily in 3 ways. Number 1, connected devices, including streaming devices, smart TVs, and gaming consoles. Examples include Roku, Apple TV, and Xbox. Number 2, popular subscription and free streaming services such as YouTube TV, PlayStation Vue, and Pluto TV. And number 3, television apps such as A&E, Watch ESPN, and Weather Nation, which are accessible through internet-connected TVs. OTT advertising is often bought and sold programmatically, meaning that the technology automates the buying and selling of the advertising in real time. This allows the advertiser to reach the right audience at the right time and puts less focus on the content that the audience is consuming. Here is an example. Jen's preferred connected device is a Roku streaming stick that she plugs directly into her TV. Jen has access to over 500,000 movies and TV shows, including original series, news, sports, and more. She can watch almost anything across thousands of free and paid channels. She can open the Pluto TV channel from her Roku home screen and begin watching live television across popular networks, including CNN, Fox Sports, and a variety of other lifestyle and entertainment channels. Jen will see commercials that are based on her location, interest, and demographics. OTT is a great way to target the hard-to-reach cord-cutting and cord-trimming audiences that aren't paying for cable or satellite anymore. OTT combines the strengths of TV and digital by bringing data that advertisers expect in a digital environment together with the TV experience consumers love. OTT is a critical addition to your media mix. Our qualified team of digital specialists are at the forefront of this digital revolution and can help you every.
So yeah, I think that's a quick demonstration, right, or some examples of how OTT plays an important role in your life, right? So that's also very related to the CDN, because if you want to have a very OTT experience, that OTT providers need to set up their contents, even the streaming things, right, in the over the CDNs. Right, for example, just mentioning the ESPN, some streaming service, right? So that ESPN service need to set up the different servers, right, across the country using the content distribution network. Okay, so that's the idea. Is the general idea for the OTT and CDN is internet host communication as a service. They just bypass some broadcast and telecommunication companies there, right? But there is also some challenges here, how to dealing with the congested internet. So this challenge is the motivation for them to use the CDNs. Okay, so OTT also have challenges, right? So from which CDN node to retrieve content, and the viewer's behavior imprints of the congestion, and what content to place in which CDN node, right? That's some open question, right? How to optimize your CDN service, right? Or specific CDN service to this OTT content, right? Because different OTT service have the different behaviors, right? So they need the CDN service to be more intelligent, more adaptive to their users, right? Uh, Definitely, I mean, if you watch a sports show, if you play the video, the people may have the different um, requirement or user experience, right? So the OTT gives some challenge to the CDN distribution networks, right? Service provider, okay? So finally, let's see an example to close this subsection or subchapter. So if the a client requests a video from http .//netcinema.com, that's a video, right? The video stored in the CDN is another server, right? Because this is just, everyone can use this same URL, but just we mentioned in last several lectures, right? So there is a DNS CNAME record there, right? So if you get this URL for the video, and the netcinema.com server will give you another DNS, right? The Bob will resolve that DNS and send the DNS CNAME to the server and get a real one, and that real one will Bob will send that URL, send a request to that URL and get the video from the real server, or I mean, depend on his location, right? Get the video from the final server, KingCDN server, streamed at through the HTTP. Okay, so that's a general process, and if this is a case study, right? So that's a general idea. But if, for example, if you are using the Netflix, and the Netflix actually put their content or put their video using the AWS service, right? So first you log into the Netflix account, and using the Netflix account to browse the video, and you decide which video you want to watch, and then the manifest file requested return for the specific the video, right? You send a request and get the manifest file, right? And then it will specifically use a dash server selected, contacted, and streaming begins with specific CDN server, right? And that CDN server should be part of the AWS service, right? But that's not the only way. There are a lot of different CDN providers. So I think that's the part of the video streaming and content distribution networks. Next lecture, we will close this chapter and end with socket programming with UDP and TCP. So we will finish application layer, okay? So I think I spend a lot of time in application layer because most of you are familiar with this layer. After you understand the application layer, different purpose, different demands, go to the another transport layer would be much easier, okay? So any question before the end of the lecture today? Okay, so if no question, okay, I see one question. Okay, so yeah, so thank you. Yeah, as for some notes and also for Bryce, you raised a good question for streaming one. Okay, so thank you everyone. See you on Friday. Have a good day. Bye bye.